Now let's move directions and start looking at circles. A few definitions that we need is that two circles with the same center are called concentric. And so that would look something like a circle with a center there, and then a larger circle with the same center. And if these were drawn completely correctly, the distance between the two circles would be constant. When we have a line segment that has endpoints on the circle, we're going to call that a chord. So if we draw a circle, and any line, it does not have to go through the center. Any line segment where the endpoints are on the circle would be a chord. Now, a diameter is a special type of chord, and it's specifically a chord that goes through the center. But a chord will include any line segment that has 2 points on a circle. Now, we also have lines that we can have with respect to these circles. We can have a tangent line, and a tangent line is a line that touches the circle at exactly 1 point. And so it's just going to scrape by the circle at any 1 point, and it will look something like that to a circle. Then we can have what's called a secant, and a secant is a line that's going to pass through 2 points. And just like the chord, it does not have to go through the center. It certainly could, but it does not have to in order to be a secant. We also can talk about angles that are in circles. So imagine that we were to draw two line segments into a circle, and we formed an angle at the center of a circle. So something like this. Here, we would call this a central angle. And it gets its name because the angle is there at the center. We can also talk about the arc on a circle. So the arc is going to be the part of the circle that is in between the two specific points on the circle that is defined by that central angle. So notice here I shaded in a little darker the arc that goes along with the central angle that we drew. But on these you also can have the bigger arc that goes around the rest of the circle. And really it goes with this central angle. And the thing with circle angles is you can now have up to 360 degrees by going around the entire circle. So let's take a look at this example. Example 5, we know that the angle DOC is 50 degrees. So that angle here in the center is 50 degrees, and that tells us that the arc that's in between those two rays also has to equal the same, which in this case is 50 degrees. Now to find the arc around the rest of the circle, AEB, whenever arcs have 3 letters, then that tells you that it is one of these major arcs, so it's something that's going to be more than half of the circle. So arc AEB is going to be 360 minus 50 degrees, or 310 degrees. So just like when we had supplementary angles, when we were dealing with lines, when we're in circles, we can have a similar idea, and an entire circle has 360 degrees. Then there's one last type of angle that we can have here in circles, and we can have what's called an inscribed angle. For an angle to be inscribed, then the sides of the angle have to contain the endpoints of the arc and the vertex of the angle that's a point of the arc. What that's going to look like is down below in figure 13.28, where you have the inscribed angle, where you see the vertex is on the circle, and then the arc between the two rays of the angle is going to be formed there. Now, the inscribed angle has a measure that is going to be exactly half of the measure of the intercepted arc. So if we look at example 6, and if we know that AC is 60 degrees, and here we know it's the arc because there was not an angle symbol, so we know the arc AC is 60 degrees. If we want to find the measure of the angle that's intercepting that, angle ABC, it would be half of the intercepted arc. So it would be 1/2 times 60, which gives us 30 degrees. Now, if you look up at figure 13.29, you're going to see that this angle R has the inscribed arc PSQ. But also notice that the endpoints on this angle that are on the circle, so here angles P and Q, notice that that is actually a diameter. So we have a very specific kind of inscribed angles. And here, when you have an angle that is inscribed in a semicircle, which means it's going to be defined by the endpoints of a diameter, then this is going to be a right angle. If you think about that, it should make sense because it is inscribing a semicircle, which is half of a circle, which would have 180 degrees in that arc. Half of 180 degrees is 90 degrees. So whenever you have a triangle formed by one of these inscribed angles and one of the sides is a diameter, then you know that you automatically have a right triangle.